Today's lesson is about evaluating composite inverse trig functions. While you're working on evaluating composite inverse trig functions, have these two charts ready. For number 1, first of all, we need to working on the inside. So we do the QRS backwards. We know that it's a negative sign because that's negative 1. We're looking for inverse tangent. Domain is negative. That's we go to this pattern, fourth quadrant. So we write down that fourth quadrant. Pattern will be negative pi over n. What's the reference angle? Reference angle will be pi over 4. Therefore, we got the negative pi over 4. That's the answer, negative pi over 4. Then we got the negative pi over 4. We need to work on sine negative pi over 4 now. This time we go to QRS. Quadrant, we carry on quadrant, that's fourth quadrant. We carry on the quadrant from here. So we got the fourth quadrant. Reference angle still the same, pi over 4. But which function we looking for, that's a sine. So we go to all students take calculus. Sine go to the fourth quadrant, that will be negative. Therefore, answer will be sine pi over 4. Sine 45, that is a square root of 2 over 2. So we got the answer negative square root of 2 over 2. This is the final answer for number 1. So we use backwards of QRS to working on the inverse. Then we use QRS to working on the trig function. For quadrant, you can carry on. For reference angle, you carry on. Then it's easier. Now let's go to number 2. Still, we're working on inverse, QRS, backwards. That's the domain for this inverse is negative. We're looking for inverse cosine. Negative inverse cosine, that's n minus 1 pi over n. So we know that's a second quadrant. Reference angle will be pi over 6. So we got second quadrant, that will be 5 pi over 6. Because this pattern, n minus 1 pi over n. So we got 5 pi over 6 for inverse cosine part. Then we're working on tangent. So we do QRS again. Your quadrant still second quadrant. And reference angle is pi over 6. I'm working on tangent. For tangent second quadrant, we know that's a negative sign. So we got the tangent pi over 6. I use this one combined here. Pi over 6, that means 30 degrees. Tangent 30, that will be negative square root of 3 over 3. This will be the final answer for number 2. Let's go to number 3. For number 3, if this one is a positive, that means reference angle. So you will figure out the reference angle, that is a pi over 3. Then you're looking for sine pi over 3, that's a square root of 3 over 2. So if you got this part is positive, then your answer always reference angle. So it's easy to figure out the solution. Now let's go to number 4. Number 4, inside, that's inverse. So we do QRS backwards. Reference angle, that's pi over 3. Negative. Inverse sine negative, that's negative pi over n's pattern. Let's go to fourth quadrant. So your answer will be negative pi over 3. Negative pi over 3. Then we go to QRS. Then we carry on that fourth quadrant. We're looking for cosine. Fourth quadrant cosine. Reference angle carry on, that's pi over 3. So for fourth quadrant cosine, all students take calculus, we know that's positive. Cosine pi over 3 means 1 over 2. So final answer will be 1 over 2. Now let's go to number 9. For number 9, we do trig function first, then do the inverse. You have these two charts ready. For all students that take a calculus, try to remember that n minus 1 pi over n, let's go to the second quadrant. And then n plus 1 pi over n go to the fourth quadrant. 2n minus 1 pi over n, let's go to fourth quadrant. And also negative pi over n, you know, let's go to fourth quadrant. So we do this part first, then we go to the inverse part. For the cosine 5 pi over 4, that's trig function, we do the QRS. We know 5 pi over 4, that's pattern is n plus 1 pi over n, so that's a third quadrant for cosine. Reference angle is pi over 4. So we do, all students take a calculus. Cosine go to third quadrant, that's negative. So you will get negative cosine pi over 4. Then you will get negative square root of 2 over 2. So this part we got negative square root of 2 over 2. Then I'm working on inverse cosine negative square root of 2 over 2. We do QRS. Since this is an inverse, you have to do backwards. So we got negative sign for domain of inverse cosine. Then we got the quadrant, let's go to the second quadrant. Remember the pattern will be this, n minus 1 pi over n. Then try to figure out the reference angle. We know that cosine pi over 4, that's a square root of 2 over 2. That's the reason pi over 4 will be the reference angle. If you want to use left-hand tricks, then the last finger folded will be the reference angle. Now we go to the second quadrant, n minus 1 pi over n. That's the pattern. That's why we got 3 pi over 4. So this is answer will be 3 pi over 4. 3 pi over 4. Now let's go to number 10. We got to do inside first, then go to outside. For inside, that's we're working on tangent 2 pi over 3. So we go to QRS. 2 pi over 3, that's a n minus 1 pi over n pattern. Let's go to second quadrant. I'm doing the tangent. Reference angle pi over 3. the sine for tangent go to the second quadrant will be negative. So I write down negative tangent pi over 3. Tangent 60, that's a square root of 3. So answer will be negative square root of 3. This is negative square root of 3. Then I go to the second step. I need to figure out inverse tangent negative square root of 3 now. We go to QRS, do the backwards. Sine will be negative. That's the domain of inverse tangent. Then quadrant, definitely you need to go to the fourth quadrant, then this pattern. So I do fourth quadrant. Reference angle, since tangent pi over 3 equals square root of 3, that's why pi over 3 will be the reference angle. Therefore, you will get negative pi over 3 because you have to get this pattern for inverse tangent of negative square root of 3. So answer will be negative pi over 3. Now let's go to number 11. The first step, then the second step. For the first step, we go to cosine negative pi over 3. Negative pi over 3, we know that's a fourth quadrant. Therefore, I just go to QRS directly. Quadrant is the fourth quadrant. I'm looking for cosine. And a reference angle is pi over 3. So for fourth quadrant, cosine is a positive cosine pi over 3. Cosine 60, that's 1 over 2. Then we need to figure out inverse sine of 1 over 2 now, because this part is 1 over 2. This is a positive. That means go to the first quadrant. You just need to figure out the reference angle because your answer pattern will be pi over n. That's since sine 30 degree equals 1/2, that means pi over 6 will be the final answer. Now let's evaluate composite inverse function like this is the one. If it's not the special angle, then what we got to do? First step, you will find the quadrant according to inverse sine of negative 4 over 7. According to this chart, let's go to the fourth quadrant. For the fourth quadrant, we will figure out the coordinate. This is a positive x, negative y. So we got positive x, negative y. Then we assume for this part equal to theta. Then you will get two pieces of information. First of all, we got the sine theta equals negative 4 over 7. Sine theta equals negative 4 over 7. Another one is we are looking for tangent theta equals what? See, tangent theta. Now we can label here. For sine is y over r. And we got y equals negative 4. Y is negative. R always a positive. Then we need to figure out that x. X will be positive. The reason why? Because the angle in the fourth quadrant is already shown here, positive x. So we do the 7 squared minus negative 4 squared. You will get square root of 33. It's positive square root of 33. Now we go to tangent theta. Tangent theta, we know that it's y over x. Y will be negative 4 square root of 33. We simplify. You will get negative 4 square root of 33 over 33. This will be the solution for number 4. Get negative 4 square root of 33 over 33. Now let's go to number 6. For number 6, this is an inverse tangent, negative domain. That means go to fourth quadrant. So we got that is a positive x, negative y now. Then we assume this part is a theta. You will get the two pieces of information. First of all, you know that tangent theta equals negative 4 over square root of 7. Then you are looking for sine theta equals what? We label this one into y over x. Remember that x is a positive and y is negative. So we got the y equals negative 4, x equals the square root of 7. Therefore, for r equals square root. Square root of 7 square plus negative 4 square. You will get square root of 23 because this is a 7 plus 16. This already simplified. So while looking for sine theta, that's a y over r. So I plug in. Y will be negative 4 over square root of 23. And you will get negative 4 square root of 23 over 23. That's the final answer for number 6. Now let's go to part 2, true or false. As we know for inverse function, f of inverse of fx, you will get x. Then inverse f of x, you will get x. Is it true for inverse trig function? Basically, it's not, because you define the inverse trig function by restricting the domain of a trig function. So sometimes it's true, sometimes it's false. How you do that? We focus on the outside either trig function or inverse trig function, looking for the range. As we know for sine x and cosine x, then the range will be from negative 1 to 1. For tangent x, range will be all real numbers. For inverse sine x and inverse cosine x and then inverse tangent x. Just look at the chart. From this chart, you got a range for inverse sine that will be from negative pi over 2 to pi over 2. For inverse cosine, they go to first and then the second quadrant. That means from 0 to pi. For inverse tangent, still from negative pi over 2 to pi over 2, but this is open parenthesis. because tangent pi over 2 or tangent negative pi over 2, that's undefined. In other words, use this chart to memorize the range of inverse trig function. Therefore, we got this range will be from negative pi over 2 to pi over 2. For inverse cosine will be from 0 to pi. For inverse tangent, that's the range will be from negative pi over 2 to pi over 2. So for number 1, we will write down the range for inverse sine, that's negative pi over 2 to pi over 2. We know negative pi over 6 in this range. That's why this is true. For number 4, range for sine function, that's from negative 1 to 1. Negative 1 over 2 is in this range, so this is true. For number 7, same thing. It's negative 1 to 1. That's true. For number 10, the range for inverse tangent, that's from negative pi over 2 to pi over 2. Then 2 pi over 3, let's go to the second quadrant. It's not in this range. That's why it's false. For number 8, you know the range for cosine is from negative 1 to 1. 2 is not in this range, so that's false. For number 11, range for tangent is all real numbers. That means this is definitely true.